Hello everyone. Today we will learn about Introduction to Kubernetes. In this course, we will learn these topics. Even we will discuss about these topics. First, we discuss what is Kubernetes. Then we discuss about container images. Then label and selectors, namespaces, node, service, pod, replication controller, replication set, deployment volume, and secret. And most of these are resources in Kubernetes or important part of working with Kubernetes. Okay, yeah. So let's begin with what is Kubernetes. See, Kubernetes is an open source orchestration platform originally developed by Google and now maintained by Cloud Native Computing Foundation. It enables automated deployment, scaling, management of containerized application across cluster of machine. So Kubernetes solve multiple problems. First is automated deployment, second is scaling, third is management of containerized application across cluster of machines. Kubernetes also helps organization transition from host-centric to container-centric infrastructure, hence improving resource utilization and operational efficiency. We will go into detail of each of these important features of Kubernetes. So let's have a look at key features of Kubernetes. So Kubernetes offer certain features. For example, application-centric management. It focuses on treating application as top priority, making it easier to configure and run them automatically. Automated deployment and scaling. Kubernetes automatically adjusts workload. It means if workload is high, then Kubernetes automatically scale up, and if workload is low, then Kubernetes automatically scale down the workload. Okay. So we will see these in some examples so we can understand this concept better. Okay, let's have a look at containerized infrastructure. Manages application and container across different machine, ensuring they are available and portable. Availability and portability are important feature of containers. Here in this lecture, container means we are dealing with Docker. Okay, Docker is kind of a container technology, and yeah, continuous development, integration, and deployment. So Kubernetes support automated application updates and deployment using tools like Jenkins, Argo CD, and Tecton. Jenkins is a CI server, Argo CD is a GitOps tool, and Tecton is also a CI tool. Okay, yeah. Environment consistency across development, testing, and production. Kubernetes ensures consistent environment across different stages using simple configuration. It is very important to maintain consistency. Only we can have a successful application deployment. Okay. So Kubernetes also offers efficient resource utilization like optimum use of CPU memory storage with built-in policies, and this efficient resource utilization automatically leads to cost saving. Okay, which we will learn maybe in some cloud course or in upcoming videos. Okay, self-healing and fault tolerance, it is one of the most prominent feature of Kubernetes. Kubernetes automatically restart failed container and replaces unhealthy node to maintain stability. So before Kubernetes, we used to have some kind of deployment script. So we used to execute that deployment script, and our application get deployed on the server. But if something bad, some unwanted event happened to our application, in that case there was no way to automatically restart. But Kubernetes offered us this facility. So this is one of the best feature of Kubernetes: self-healing and fault tolerance. Now I will explain you a bit about advantages of Kubernetes. Okay. So first advantage of Kubernetes is scalability. Kubernetes automatically scale up or down based on demand. It handles dynamic traffic pattern, adjusts resources accordingly, and it ensure application are highly available. High availability also has economic benefits. Okay, if user doesn't have good experience, like user try to access your application and your application is not available due to any reason, then it leads to bad experience of customer, and automatically you will have bad economic bad business. Okay, so high availability and okay, load balancing. Kubernetes has inbuilt load balancing to distribute traffic across containers effectively. It enhances application performance and reduce the risk of server overload. Self-healing, I already discussed this topic. It is one of the best feature of Kubernetes. Kubernetes automatically detect failed containers and replaces or restart them. Ensure that system remain healthy and application continue to run without manual intervention. Okay. Portability, like application must run consistently across different environment. Okay, on premise, cloud, or maybe hybrid. Cost efficiency, yeah. So as we have better resource utilization, we have uh, we have like it lead better resource utilization leads to cost efficiency. Okay, we could save our money, especially if we are dealing with some cloud or some production infrastructure. Okay, so here we are, yeah. Now if we want to go further with Kubernetes, it is important to have some understanding of containers. In this lecture we are dealing with Docker as a container, so we must have understanding of how Docker works, how Docker images are created, how they work as a standalone unit. And to reach advanced configuration in Kubernetes, one should understand basic networking and how protocol communication works. In case you don't understand Docker very well, then I would like to recommend you. I created a small video on Docker for Kubernetes, which you can watch and have some understanding of Docker. And then you can start watching this video. Okay. So now I explain you how Docker and Kubernetes work together. Okay. So here I have created a Docker file. I created a build. Using build command, I am able to create an image. If everything is fine, then Docker image will be created, and then I can run the container locally. Okay. After creating image, I push image to the Docker hub or any other registry, and then Kubernetes pull that image from registry, and then Kubernetes run that container inside the cluster. So that's how Docker and Kubernetes work together. And now I explain you a bit about Kubernetes cluster architecture. Okay, one more thing before we begin with Kubernetes cluster architecture, I want to share one thing that I will be doing some practical example, and it is important to have local Kubernetes running on your system. I am using Minikube. Okay, you could also consider using some other Kubernetes node, for example, Kind or Minikube would be most suitable for this lecture. Okay. So Kubernetes master. So it is a master node. It is a slave node. So you can see in every slave node you have three components: Docker, Kubelet, Kubernetes proxy. Okay, here we have a master node. I will explain you all these concepts later, but first I explain you the slave node. Okay, in slave node we have got three components: Docker, Kubelet, and Kubernetes proxy. So Docker, as I mentioned, that it is a container technology, and it package with the help of container. One can package everything required to run a piece of software. Everything stands for runtime environment, all dependencies, library, tool, whatever is required to run a piece of software. Okay, that you can package in a container, and you can run the container in a suitable environment. Suitable environment stands for an environment to support Docker. Okay. So for example, if I have a Windows machine, then I must have a Docker desktop installed in my system, and Docker must be running. Okay. For example, if I show you here Docker desktop, yeah, so it is running. Okay. Okay, so to work with Kubernetes, as I mentioned that I'll be using Minikube. So here is a Minikube. Minikube start. Okay, so here I'm getting this message in German language because my system is configured in German language pack. Okay. Uh, okay, so I'm getting failing to connect, but here I'm getting some external image. Okay, so now I see this message. Now if I want to see this kubectl cluster, yeah, and see my Minikube is working right now. Okay. Okay, so now we will discuss about kubelet and Kubernetes proxy. Okay, so what is a kubelet? Kubelet is kind of a node agent in Kubernetes that run on each worker node. Ensure containers are scheduled to node are running and healthy. It is a local manager for everything happening on the node. Interacting with the runtime environment like Docker or Containerd to manage container lifecycle. I already mentioned about Docker. However, I cannot discuss Containerd in this course. I probably make another lecture in which I discuss about Docker and in detail. So then I will explain you about Containerd. Okay. So it is like a manager, local manager. Kubelet is basically a local manager, which is responsible for everything happening on the node. Okay. So whatever is happening to manage container lifecycle. Okay, so now I explain you about kubeproxy. Kubeproxy is a networking component running on each node within a cluster. It acts as a network proxy and load balancer, ensuring traffic to services is correctly routed to appropriate nodes. It essentially manages the network rule required for service to pod communication. So here we have a kubeproxy. It is responsible to ensure traffic to services is correctly routed. Okay. Yeah. In case you have some questions, then please write me in the comment. I will certainly try to answer you as soon as possible. So now we move ahead with the images. Okay. So in Kubernetes, container images are fundamental unit for deploying application. Each container within a pod run a specific image, which include application code and its dependencies. Defining container image is when configuring a pod, we specify the image to use for each container. The image follow the same syntax as Docker command does, and we can pull image from public registry like Docker Hub or from private registry. Here is a pod configuration. So I have already explained you this concept. We specify image to use for each container. The image follow the same syntax, and we can pull image from public registry. As we have explained you that this is a Docker, it will pull image from public registry and run the image and run the image and create the container out of it. And yeah, and now I will show you some pod configuration. So here we have API version v1. This YAML file is of kind pod. Here we have an image name, then we associate label app as image test, and then we have a spec name as neo4j server, and name of container is neo4j server, name of image is neo4j 5.14. Image pull policy is always, and if everything goes well, then it will be echo success. It will be we will see this message. And here we have defined the resources, like how much memory is required and what is the limit, so our pod must not overuse the system. Okay, and here we have container port 7474, and we have got restart policy never. Okay, so let me explain you a bit about this thing. Okay, so this is explanation of configuration. Okay, so metadata name, we have pod testing for image. So this is our metadata name. Okay, container name, so this is the name of our container, neo4j server. Here this is the name of our image, neo4j 5.14. And pull policy we discuss in detail. Okay, but for now we set it as always, I think. Yeah. Okay, command, once everything is goes fine, then we will be displayed a message when we access the container. Okay, and resources specifies CPU and memory request, and limit, we have to set limit, so overuse could be avoided. Okay, then we set the port. Even though test doesn't expose neo4j, we demonstrate how to define port. And we have got restart policy, which we set never. Since we are using this as test container, we don't want it to restart on completion. Okay, so this is an explanation of this YAML file. We will certainly do an example, but before that, let's understand a bit about image pull policy. So there are basically three kind of image pull policy. First is always. Always mean Kubernetes pull the image every time the pod start. Ensure the latest version is used, and if not present, like if we specify image pull policy as if not present, then Kubernetes pull image only if it is not present in the node. And if I set image pull policy never, it means Kubernetes never pull the image. Image must be present locally. Okay, and there is important thing to note, especially from the production point of view. It is important to note that relying on latest can lead to unpredictability, as image it point to can change over time. For consistent deployment, we should specify exact image tag. Okay, this is very important, to not use latest but to specify exact image version, especially in production environment. Otherwise you will have unpredictability. Okay, it lead to some issues also. Okay, so let's time to create one example. Okay, so I just find my Kubernetes directory, so I can create some examples. I created some example before this creating this video, but it's important to recreate everything. VS Code, let's begin with VS Code, and okay, so we have got first example, and first example is neo4j demo. Okay, let's name it as neo4j demo dot YAML. Then I copy this thing. It might have some YAML formatting issue, so I check it with YAML formatter that everything is fine or not. Okay, because if it is not let's see. This is not the right source, I think. Maybe this one is better. So okay, so can you please format this YAML file? Let's see. Yeah, it seems it is quite fine, and okay, so this is working fine, and now copy path. Okay, so kubectl neo4j made pod yaml. Okay, I put it as neo4j demo. Okay, so I can use the same neo4j image pod. Neo4j. Oh, okay. अरे neo4j image demo yaml. Okay, so I created this, and kubectl apply neo4j. Let's see what happened. Okay, it is already created, so I am getting unchanged because I already created this thing before creating this video, so that's why I'm getting this message unchanged. Otherwise because I did not change anything. Okay, but if I change something, let's see what happens. If like if I put it like this, and then if I do it, then yes, something is happening, or it is bad or good, I don't know. Forbidden. Aha, I'm getting an error. Okay, so I'm not allowed to make this change. Okay, what if I change the port? What would happen then? I do one thing. It already exists. Okay, so first I delete it. I can also update it, but yeah, it is created. Yes, it is created. Okay, so yeah, now we copy this command and let's see what happened. kubectl get pod testing for image. It is not found, so I think I may have used some other pod name. Testing for image pod. Testing. Aha, okay, I made a mistake actually, because it is normally it must be this, but yeah, now if I put this, it is a spelling mistake. Okay, so here we can get this response. Okay, so it is not yet ready, but status is complete. Okay. So this part of example is done. Okay, now we proceed toward the best practices of specifying Kubernetes YAML file, especially how this deployment and other files we write, and what are the best practices for those files. So first is specify exact image version. As I mentioned already, that here we see that we must not write latest, we must specify exact version. Okay, so it will ensure consistency across deployment. This is one of the best practice. Okay, use image policy always for critical updates. If we have critical updates, we must use always, not other policies like never or if not present. We must avoid using those image policies. Okay, for example, for application where It is crucial to always use latest image during development. Okay, set image policy to always ensure Kubernetes check registry for latest image each time the pod start. Okay, we must leverage image digest for immutable deployment. Use image digest, for example nginx at the rate to sha256. It ensures exact image version is used, providing immutability and preventing unexpected changes. Okay, so monitor for image pull error. This is one of the common error, especially when you begin with Kubernetes. For example, you specified incorrect image name, or you might have some authentication issue with the registry. In that case, you could get these kind of error, image pull back off or error image. So this is like for beginners. This kind of error could come, and you must try to fix why you are getting this error, that you can and the reason you could find in the log file. Okay, image, either image pull back off or error image. And what are the reasons? As I mentioned, that image name or missing images, or you could have some authentication problem. So okay, you must see these reasons and try to fix your issue in case you get. Okay, so here we completed till best practices. Now we go through the Kubernetes job. Okay, the main function of a job is to create one or more pod and track about the success of pod. They ensure that a specified number of pods are completed successfully. When a specified number of successful run of pod is completed, uh, then job is considered completed. Okay, so here we have an example of create pod. Like this is a one YAML file again, and its kind of resources job, and metadata name is py, template name is py, spec container name is py, image is python, and if everything goes well, then python success, and restart policy is never. Okay, so let's do this example again. Okay, I will certainly have some issue, but yeah, without issue we cannot learn. Okay, okay, so this is one issue. What I can do, again I will type here. Okay, then I copied it here. Yes, this batch is very important for this Py API version. Okay, so let's validate it from here. Okay, now we don't see any issue here. Copy, paste. Let's see what happened. Error already exists. So it seems like I already created image with same name. So first I delete it. It is deleted, then I create it again. Let's see, it is created. Get py. No, I have to specify the name of pod. What is the name of it? It's py. Okay, get pod py. It's not found. Let's see what is the py. Okay, we have got another. We have got py, but with a different name. Okay, I think this value is automatically added. So P9 VXM. Let's see, it is also completed. We can describe. We can use the command describe, so we get to know more information about it. Okay. Okay. So we have got some more information about it, like we wrote kubectl describe pod, pi hyphen p9 vxm. So here we are getting name, namespace, priority, and then we are getting information about the container. Okay, and then we got success. If state is terminated, reason completed. Okay, the reason it is completed. Okay, and the condition, here we are getting condition. We'll go into detail of all these things. Okay, so I'm just giving you an overview, like how we create pods and how we get to know more information about pod, how things are going with it. Suppose we get some error, then we could have got some information from here, so we could fix our error in the pod. Okay, so yeah, we are done with this example also, and now I'll explain a bit about this, like kind is job. We have defined this, the kind as job, which will tell kubectl that YAML file being used is to create a job type pod. Okay, so pod is of job type. Then we specify name as pi. This is the name of the template that we are using, and spec define the template. Okay, it is under the spec, like under spec we have got a name spec, this is a pi. Okay, then we have an image Python, the image which we are going to pull to create the container which will run inside the pod. Okay, I do one more thing. Okay, I go here, cls get pod. Okay, so I created a pod. Okay, now I delete it. Okay, I deleted it. I saw nothing is there. Then I can create it. But before creating it, I do one thing. Image is Python. Ab I do something like this. I write it like this. Okay. I hope this image is not available. And let's see what happened. Okay, it is created. Apply. Let's see, apply. What would happen after if I apply? Oh, I put the wrong name. Then, okay. I think I better study about describe. Okay, wait a moment. Okay, first I see what is my pod. Okay, here see, you see error image pull. This is the error I am getting, and why I am getting. Let's go to the description. Okay, describe pod pyvz2et pyvz2et, and we get answer. So this pod is not able to pull this image. Okay, why I created this example? Because I want to show you this thing, error image pull. Okay, this is the purpose of creating this example. Now I fix this problem. Let's see if I recreate it, what happened, that it is already created. Okay, do we have option to update it? Or let's delete it first, because right now I want to have simple. Okay, completed. You see, it is completed. That time it was showing us error image pull. Now it is showing completed. So this is one of the advantage of having correct image name, and in case we don't have correct image name, then we will certainly get some error. For example, we got error here. Okay, so we are done with this example. Here we also explained you, I also explained you this thing. Okay, I also described you this thing. Yeah, so now we have to begin with scheduled job. Okay, Okay, so in schedule job in Kubernetes uses Kubernetes, which takes Kubernetes job and launch them in Kubernetes cluster. Scheduling a job will run a pod at a specified point of time. So in case we want to schedule a job at a specified point of time, then we can consider using this schedule job, and I'll show you how we can do it. Okay, okay, here. So here we have like schedule h/30. S/30 stands for every half an hour. Okay, and here we have like 4 stars, and this clearly means that this job will be executed every half an hour, and this configuration is quite similar to the previous one, but however there are some differences. For example, this restart policy, in case pod get failed, then it must restart only on failure. Okay, so here is a small description of it. Like, yeah, it must be to schedule the job to run in every 30 minutes. This will enter in container. Okay, with when you specify this command bin/bin/sh, it will enter in the container. It will run ps-ef command on machine and list all running processes inside the container. This schedule job concept is useful when we are trying to build and run a set of tasks at a specified point of time and then complete the process. Okay, so now we have to begin with labels and selectors. Okay, selectors are very important, especially when we are dealing with different pods, and some pods are dependent on others. So, especially, yeah, when we are dealing with multiple pods. Okay. However, labels are also quite important to us. So both are quite important. Okay, so what is the difference? Okay, let's begin with the labels. Labels are key value pair which are attached to pods, replication controller, and services. These three are resources in Kubernetes. They are used as identifying attributes for objects such as pod and replication controller. They can be added to object at creation time and can be added or modified at runtime. Okay, label. uh, okay, so we have got label. Okay, why do we need selectors then? So labels do not provide uniqueness. In general, we can say many objects carry same label. Label selector are core grouping primitive in Kubernetes. They are used by users to select a set of objects. So basically, selector offer us uniqueness along with similar functionality to labels. That's what we understand from this content. Okay, yeah. Kubernetes API currently support two type of selectors: equality based selectors and set based selectors. Equality based selector, they allow filter by key and value. Okay, key and value, and matching option should satisfy all specified label. Set based selector offer filtering of key according to set of value. Okay, so here we have a YAML file for set based selector. Okay, so its kind is service. Okay, and the spec port is node port. We'll discuss about node port service bit later. Okay, so just have a look at it, and maybe I explain you a bit. Okay, in above code we use label selector as app sales platform. So here we have app sales platform, yeah, selector as app sales platform. Once we run the file using kubectl command, it will create a service with name sp neo4j standalone, which will communicate on port 747, and YPE is node port, and the type is node port. Okay, and the type is node port with new label selector as app sales form. So let's do this example. Okay, so I specify it as neo4j selector demo.yaml. Okay, and then I take my YAML file here on ChatGPT, so it can automatically format it. I don't know why it is why it is loading image. Okay, so here I got this. I checked it. Okay, so things are working fine. Okay, so I pick up this thing here and oh, okay, now I go here. Neo4j selector demo and service is created. CSPJ Neo4j. If I want to describe it, we'll go into detail of all these surveys and these stuff. Let's see it, what is happening inside it. Okay, so we can get this information like selector name is app sales platform component Neo4j. What is the type is node port type. We will go into detail of node port. Okay, so yeah, so far we have reached here, and yeah, now we begin with namespaces. Okay, but before that we take a small break.